Stefan is the author of books, so he wrote a TypeScript book, and we were honored to receive the books last year. Very good book, very good. Loved it.
Great.
So, yeah, and he's going to talk about, you guess, TypeScript. So give him a round of applause. And
thank you very much. Thank you for this lovely introduction. So, welcome to my talk, Lies We Tell Ourselves Using TypeScript. I have to make an apology. I'm sorry. So, this is a conference you're supposed to get excited about new stuff, about new technology. You have to find out what's new in the Angular space. This is not going to be a fun talk. I will crush your hopes. I will destroy your dreams, and I'm genuinely very sorry about that. So, as said, I work a lot in TypeScript, so I've been doing TypeScript for 5 to 6 years, and I really dug deep into the type system. And usually, when I'm giving talks, I talk about the benefits of TypeScript. So I showed this contrived example. I created this JavaScript example, which compiles, so it parses, it doesn't throw an error, it just doesn't work. And TypeScript helps us figuring out that every line of those 15 lines actually has a bug. So this is fantastic. It works in JavaScript, but every line is actually buggy. I'm not talking about this today. Instead, I'm talking about the exact opposite. So this is something that I pulled out from some SDK that I got, which is basically the opposite. It's TypeScript code. It checks, the type checker compiles, everything is okay, it doesn't throw any error, those types are nice, but it fails miserably at runtime. You know, that time where TypeScript is supposed to help us. Don't look at the code right now. We are going through it step by step. But first of all, let's look at the types. So we created a couple of types. The example fetches some data from some API. To make it a little bit more tangible, I used the Swappy, the Star Wars API. You know, swappy.dev. You can just use it as a demo REST API. We want to write a function that fetches 2 types of data, either Swappy species, you know, by going through the species endpoint, or Swappy people. Those are pretty much standard fare. You have property names on the left side, you have strings on the other side. And somebody even used string template literal types to make sure that those URLs are also well typed. That is nice. Then we have some meta type to wrap the whole thing. So we have count of number, the number of elements that you get with each response, a link to the next URL, a link to the previous URL, if there is any, and the results, you know, wrapped in an array or an array of the results, which we then can iterate over it. And we are interested in that results property. Now for the main act, let's look at the code. There you go, let's look at the code. Yeah, there it is. So we have 2 functions. One fetches data. It has a simple fetch call. It calls result.json. The other function concatenates the fetched results to an existing array. We can talk about style or API design, but in the end, you know, that's code that I or you or anybody of us could have written. And again, this is pulled out from an actual SDK. Somebody has written codes like that. And I want to ask yourselves, I want to ask you and myself, what do you think could go wrong? Everything. Where could it go wrong? Everywhere, good. When could it go wrong? Actually, one by one, because we're single-threaded. But a quick, my most favorite JavaScript joke is, knock, knock, race condition, who's there? But okay, sorry about that. Let's go through it step by step. The code is a lot to unpack, I give you that. So it's really a lot to unpack, so let's unpack it together that we understand what's happening. This is the core of the first function. We fetch some data from the Swappy, then we parse it with the result.json call, and then we return the results. We are not interested in any meta information, we just pick out the result property. This piece is interesting. The developer was smart. They knew that if you call result.json and you're not getting a JSON file back, that it causes a syntax error. So they check for a syntax error, they catch it, and well, they throw another error, but you could just as well have some mitigation there, like returning an empty array or whatever. Just works as well. This is also very interesting. We have some function overloads. So function overloads are a really nice feature that I use a lot in TypeScript, where you can define an API that's easier to use, that's much, much more comfortable to use, and have all the dirty implementation details hidden from your users. For an SDK, fantastic. This is perfect. And at the end, yeah, pretty simple. We have an append entries function. The only thing that is really interesting is that you have an await call, so you can pass in a promise, but that's just a detail. It basically takes an array of people or species and concatenates it with another array of people or species. And then we are using it. Good. Okay, so what's going wrong? Chapter 1, at Hello Fetch. There is some damned lie hidden in this statement. I'm doing here type annotation. Let data meta swappy people. I say that what comes back from result.json has to be of type meta swappy people. And this line only works because the JSON method from the interface body returns any. And any is the happy-go-lucky type in TypeScript. Everything's possible. And if you say so, then TypeScript is just OK with it. So, oh, that's fine. If you say it's swappy people, then it's swappy people. I'm good with it. And you know, nothing in that call actually tells us that those are swappy people. This might go boom. This might break. If we call any other API and not people, we are getting the type swappy people back. And nothing can prevent this. What we are seeing here is TypeScript at its boundaries. This is where the meta world of your types meets the ugly, dirty reality. Oh, I love it so much. And this is also where TypeScript's type system is fragile, you know? This is where it meets the boundaries. This is where it needs to resort to information from the outside. This is mostly I/O, you know, API calls, user input, you name it, everything where actually something happens, you know? And this is where you need to make extra checks to make sure that whatever happens is actually what you want to happen. Now look at those two different ways of making this call. The first one we already saw. It's like we annotate data with meta swappy people. This is a type annotation. And the other one is interesting because here we are making a type assertion. We say as meta swappy people. You know, to basically do the same. After that, data is of meta swappy people. Fair enough. But there is a very delicate difference between those two calls. One is just, yeah, using what TypeScript does. So TypeScript is OK with that. And the other one is an explicit decision by us to say, whatever happens here, we, as developers, assert that this is meta swappy people. This is not a tool that does it. This is us. This is our decision. I like to call those things unsafe operations. Unsafe operations is where TypeScript needs a little bit extra help from us to say, well, this is something that could go wrong. This is a special syntax we use for that. And with the as swappy people, as meta swappy people, we are also able to find it later on. If something breaks, we can just do a full text search for as, and then we have all our situations where stuff goes wrong. And there are a lot of things in TypeScript that are those unsafe operations. Like we have type assertions, we have type predicates. This is if something is of type dice. And you have also things like assertion signatures, which work kind of like type predicates, but in a different control flow. So this is good. It is good that this exists. It's an indicator that we bend the type system to our needs because we know more about what's happening. And we can tell TypeScript, you know, at this point in time, we assert, it's our duty, it's our responsibility. We assert that this is the correct type. So embrace it. Except that we can simply override it with fucking any. I'm sorry. And there's nothing we can do with it, because any is just hunky-dory, happy-peppy with whatever it gets. Cool. That's one thing that we could do that helps us prevent that, which is unknown. You know, the type, the cautious sibling type of any, it has the same set of values, but it doesn't make any assumptions. You need to make those assumptions. And there's one way to make sure that whatever comes back from result.json is actually of type unknown. This works for a little thing called declaration merging, where we are able to open up existing interfaces and add new methods and new functionality to it. And in this case, we open it up and add another JSON method to it that overrides the previous one, where it says, well, actually, if we call .json, it's a promise of unknown, not of any. And now that I have that, the only thing, there you go, there you go, there you go. Now that I have that, I'm getting a type error at this particular point in time. Let data, meta swappy people, await result.json. And the only thing that helps me now is a type assertion, or I use a library called sort to validate my data, something like that. It's now our responsibility and our duty to do something, and we can't avoid it because otherwise we're getting a type error. Type error like this one. Type unknown is not assignable to type meta swappy people. This is us saying, well, this is the type checker telling us, are you 100% sure that you want to have this type? Okay. First mitigation for the first problem. The next problem, the theme is dark and full of errors. There was one line that caught our eye. This particular line where we are doing error handling. So we are catching for a syntax error. It's interesting. It's curious. You might ask yourself, what were the intentions by the developer to produce this particular line of code, which is a nice way of saying what were they thinking. But hey, actually, if you analyze it and if you think about it, the thought process makes sense. Never blame the developer. Never blame the developer. Always blame the tools. It's the tools that make these things work. But this is actually one of the most honest mistakes that you can make. What's happening here is that result.json can, in fact, cause a syntax error. So we try to catch for a syntax error there. The problem is that, first of all, you only have one catch clause in JavaScript. And second, you can't catch for a syntax error in TypeScript or JavaScript. You just can't, because in JavaScript, everything can throw. You can throw the number 2, you can throw undefined, you can throw everything. You can be like my 2-year-old and throw tantrums. Fantastic, just do it. Or I don't know, like a monkey in the zoo, they're also throwing stuff at the audience. In JavaScript, you can throw anything. This is totally fine. This is why you have only one catch clause, okay? And if you look at that code, this is also where this little any snuck in, because, well, the developer thought, well, it could be a syntax error, but in reality, it could be anything. And if you have a union type of a syntax error or any, then the whole type becomes any, because any is every value. So syntax error is also in the value namespace of any, which makes any the entire set that we are catching here for. So if we call e.message, it's because, well, any allows us to call e.message. There's another mitigation for that, the same one as before. Let's use unknown in a catch clause. This works, the same set of values, but cautious. We need to do something about it. And let's do instance of checks to make sure that the error that we are catching is actually the syntax error that we were looking for. It looks like that. It looks like that, exactly. So we say e is of type unknown, and then we see e instance of syntax error and append the message to it. Fantastic. You can also activate use unknown in catch variables in your tsconfig JSON. Then e is by default unknown. Great feature. Definitely activated. Second problem, second mitigation. Chapter 3, the matrix overloaded. At the end of the talk, you will notice that I have lots of movie quotes in there. And you know what? We already have plenty of problems for, I don't know, 4 or 5 lines of code. Let's see what's in store next. So I want to turn your eye to the function overloads. The function overloads tell me that I get swappy species if I ask for species. Okay. But in the code, I only return people. The signature tells me I get species. The code tells me I get only people. Again, the signature tells me I get species, but in the code I only return people. I'm sorry, seriously, how can this happen? So I can just say anything in those function overloads, and TypeScript will be okay with it. And then I return just something, well, whatever I like at this moment. It doesn't matter. Jesus Christ. So, but this is because of the way function overloads have been designed. Those are all the signatures that I have. And you can split them up into 2 parts. One part is the API for usage. So this is the API that you expose to your users or to yourself. This is how this API is supposed to be used. And then you have the actual implementation. This is just a function like any other else. So the only thing TypeScript checks here is if those lines at the top are somehow fulfilled by the implementation. So are the sets that we define on the top can they be found in the implementation as well? And if that's the case, TypeScript is okay. Starting from there, it's your responsibility to do the right thing. Again, it's your responsibility. You need to make sure that you return the right things at the right time. But nothing helps us in doing the right thing. So this is something that you need to be aware of. One mitigation that might be is actually having conditional types. Conditional types, you can kind of do the same API, the same parameters and return types that you can do with function overloads. So in that case, I check, well, is the string type species? Then I want to have swappy species. Otherwise, I want to have swappy people if the string extends people, which means is it of that particular kind of string. And when I do it like that, I use this as a new function signature, list entries of generic parameter t. The moment I add a certain kind of t, it can figure out the return type. That works pretty well. And the good thing is, this is a very complex thing for TypeScript. So TypeScript says, well, if you have this as a return type, I actually can't figure out if everything that you do is actually working. Which means that we are getting another type error which tells us, you know what, you're returning something where I can't figure out if that's actually the case. And we're getting an error where it says, well, the stuff that you're returning here, swappy people or swappy species, I just adapted. Okay, the laser pointer doesn't work here. I just adapted the function that it does actually the right thing, you know. The type you want to return here, I don't know if it maps your function signature. Please make sure, it's your responsibility again, make sure that this actually works. So what you can do is just have another assertion signature and you say, well, this is swappy return of t, it returns an array, and you are good with it. If something is afoot, this is then where we should look at. Problem 3, mitigation number 3. The next one, the unexpected virtue of ignorance. If you know what kind of movie this is from, please go talk to me in the break. It's one of my favorite movies. Anyhow, this is also arguably one of my favorite problems in this whole bunch. I'm having this append entries function here, and it's cute, it's little, it doesn't do that much. So we have this list, it's an array of swappy people, swappy species. We have this from parameter, which is a promise that also returns an array of swappy people, swappy species. I concatenate them, I have one big set. Okay, fantastic. That's great, that's all it does. And then I use it. So one thing, the one thing why this works is actually that lists, arrays, objects, whatever, are passed by reference. And you can mutate them inside this function. This is what's going on here. So we are only able to concatenate it because it's passed by reference, it's being mutated, and then you have the mutated state. Then I use it. I have, let list is swappy people. I'm creating a new array of people, and then I call it append entries list, and I concatenate species to it. So the question to the audience, what's the type of list after append entries? Any idea? It's still people. It's still people. I just appended species to it, but the type is still people. So why is this happening? Because all the contracts are fulfilled. So TypeScript says, well, the contracts of the functions are fulfilled because you're adding a union type to another union type, that's okay. And then you just pass in the parameters, that's also okay. And why should it change the type? So this is one limitation of TypeScript, where it can't change the type after mutation that happens inside a function. This is not possible. So TypeScript does not check your control flow inside the functions and checks if something could happen that widens the type that you actually have defined. Limitations. One mitigation is adding generics. And generics are really one of those silver bullets if you have any type errors. Here I'm having the function append entries. I'm using a generic now that points to the same set as before. I want to have an array of people or species. That's okay. But I use the generic type parameter, which means the moment I use the generic type parameter in list and in from, and the moment I use it down there when I call the function, T gets instantiated with the type of the first argument. So the moment I call append entries list, T becomes swappy people, not swappy species, because it's a subset of species or people, so the type checks out, but it creates, how do I call it? It creates a concrete concretization of this particular type. So we can pick out one exact member, and that's it. Which means I get the type error here because it tells me exactly what I'm supposed to have. You can't assign the type promise swappy species to the parameter of type swappy people. Fantastic. So this is a really, really good way of mitigating those things. Alrighty. Everything mitigated. 4 problems, 4 mitigations. Every potential problem has now a solution. Please enter the final chapter. Alrighty, the story so far. We found 4 mitigations. 1, declaration merging to patch assumptions. The second one, instance objects and unknown to narrow down error types. Conditional types instead of function overloads to highlight unsolved operations, and generics to narrow down to specifics to concretizations instead of having this wide array. Beautiful solutions for our situation, but I have to tell you, and I'm very sorry, those are also just more lies. Lies on top of lies. So, here's an interface form data. I define 2 properties, and the moment I call handle form with form data, I see that I have API available that I have never defined anywhere at all. Where is this coming from? So, declaration merging is really great unless you accidentally merge with globals. Nothing in TypeScript tells you that this is happening. You just need to figure it out that suddenly you get more for the dozen. So yeah, be aware. Declaration merging, not silver bullet. Instance objects. This, I guess this is my favorite one. Seriously. I have 2 classes, class R and class B, and I have a function that accepts both R, A, and B as parameter. And it does instance objects, you know, to make control flow analysis, to know how to access the right property. And at this line console log p.a, TypeScript is sure, because of the instance object, that this is of type A. At the other line console log p.b, TypeScript is 100% sure that this is of type B. This is great, fantastic. This is how it's supposed to work. You're creating an instance, then you're doing an instance object, and TypeScript knows all about it. Except that you realize that TypeScript actually has a structural type system, so you can pass literal objects just like that, as long as they have the same shape as the instance of one of your classes. It has the same shape, it has the same type according to TypeScript, but it's not an instance of A. It's not an instance of A, which means that this runs into the else branch, you log out undefined, or if you're actually doing something with your properties, you're creating a beautiful runtime error and your application crashes. You know, those things TypeScript is supposed to get rid of. So instance objects are great until you realize TypeScript is actually structurally typed. Okay. Line number 2, now line number 3. Conditional types, well, yeah. I'm so sorry. Do you know what this conditional type is supposed to do? Me neither. But you know what? I wrote this. I wrote this 1 month ago. I have no clue what I did there. So actually, no, seriously, I wrote a book where I explained it in 5 pages. And I guess I just wrote it for me at this point in time. But you know, conditional types, great feature, powerful feature. You can do a lot of fantastic things with it. But seriously, you have to ask yourself, are the benefits worth the complexity that you buy in? Because this is its own programming language that works in a totally different sphere. So yeah, conditional types, the next lie. Yeah, and generics are, generics are great until you explicitly widen generics and you have the same problems as before. So hey, how are they? How are they a solution? How are they a silver bullet? They are not. All of our solutions debunked again. Again, I'm sorry. Okay, for the end of my talk. Again, I'm sorry. This wasn't a nice talk. So I hope you didn't get your hopes too high. And then you had two fantastic introductory talks this morning, which were exciting. We told you what is happening in the world of testing and in the world of Angular, and now you have this grumpy old guy on stage who is complaining and throwing tantrums because he's been working 5 years with TypeScript and figured out that everything is not so shiny as it's supposed to be. So you might ask yourself, what do I think about TypeScript? to be honest, I fucking love TypeScript, seriously. So I fucking love TypeScript. I wouldn't want to work without it. The thing is, it's the second best programming language I have the pleasure to work with. And a couple of you know what I'm aiming for. And the truth is, it makes me productive as hell. And this is also the biggest goal of TypeScript. The goal is not to have a provably sound type system. It isn't. It's explicitly a non-goal. If you look at the design document of TypeScript, it's all open source, it's all out there. It's not a goal to be provably sound. The first goal of TypeScript is to make developers productive. And this is what it does. It makes some trade-offs. It makes a lot of trade-offs, actually. We have just seen 4 trade-offs, or maybe 8, or maybe 20, I don't know, that it makes to get you to this productivity. But you can't deny that it makes you productive. I wouldn't want to write JavaScript without it. And honestly, I think it's a tremendous effort what the TypeScript team did to take a language like JavaScript and they create a type system around it that works so well, despite all the caveats that there are. And this brings me to the core of this talk. So yeah, I've been throwing tantrums now for half an hour. It was fun, or maybe not. But actually, there's one message that I want to conceive today. Software engineering is all about decisions and trade-offs. You are all software engineers, and every line of code that you write is a decision you make and is validated against the trade-offs you are willing to make. And choosing TypeScript as a tool is also a decision that you made and also has certain trade-offs. And this is also what the TypeScript team does. They know about trade-offs. They're doing them all the time. They're some of the smartest people that you are able to get on the planet, and everything they do is making trade-offs so you can stay productive. So I'm not here to tell you what to do or what not to do. I'm here to make you aware of decisions, of trade-offs, and of all the caveats that your decisions bring with them. Everything that you've seen today, use this to make more informed decisions in the future. Use this to make the right decisions for you and your team and your product and your goals. Validate them against what you want to do. There is no silver bullet. There is just, well, lots of tools in your toolbox that can be used for different things. And you know, all the solutions that I showed, they are not the best solutions. They are just, you know, solutions. They might help. They might also not help. It can work for you, or maybe it doesn't. And yeah, and please don't go for hot takes or dogmas. So this talk is not something that might go viral on YouTube because of 5 minutes of hot takes. And yeah, I know, I'm very well aware that Bernhard, who is sitting back there, told me that this is fantastic phrase to end the talk, but actually it's very dogmatic advice. So take it with a grain of salt. And you know, with that, I think TypeScript is fantastic. It allows us to pick and choose the right tools for our projects, for what we want to do. I fucking love TypeScript, and I want to thank you very much for paying your attention for 30 minutes. Thank you for having me.